The software, open this. Okay, after that there are, if any temporary files are there, you go for project. There is no option here, so therefore go for file, then close project. In the older versions, options will be there in the project, but in the newer version you are having in file, close project, temporary project, then go for file, then create new project. So select D or E drive only. In some computers you are having only D or only E, like that. Go for D or E drive. Select D, give your user number or your name. Okay, give your user number or name. I am giving prog1 name. Okay, in location UB34. Okay, next. After that, check the family. Family is Spartan 3, device is XC3S200, package is TQ144, speed is -5. So this is normal declarations in the specifications here. So synthesis tool is Verilog, simulator is already declared here, language is Verilog. Okay, so this already will be available here. So simulation tool is iSim simulator. So next, finish. Same as HDL what you are doing, but some instructions you have to note down. So you are getting the package here, XC3S200 and speed -5 with TQ144. Yes, okay, so go for, again right click on this package, right click, then left click on the new source. Left click on the new source, then select Verilog module. Right click on this, left click on new source, select Verilog module. Give the module name as, first you are doing inverter, INV1 you are doing, INV1, you select that one. Next, so what is the input and output for inverter? A is the input and B is the output. Next, finish. Okay, so give the same code here, syntax code, A comma B. So input will be A, output will be B. Give the supply 1 VDD, supply 0 as VSS, then PMOS P1, open the bracket. So what is the drain region there? B is the drain region, I think. B, yes, comma VDD, comma A. Then NMOS N1, open the bracket, B comma VSS comma A. So this is the code. We call this as a Verilog code. So this is switch level code. So check syntax here. Okay, it is corrected here. So it won't synthesize here. If I synthesize it also, it won't synthesize because it will not included in the library. Unsupported switch level code is unsupported in Verilog. Therefore, it will be showing into, but it will going to check the syntax and it will generate the waveforms. So after that, what happens? Again, right click on this. Go for again new source. Go for Verilog text fixture. So initial Verilog module completed. Now another thing is Verilog test fixture. So select the another name. So INV test 1. INV test 1. So select another name. So see, the test bench code is generated here. At the initial level, you have to make changes here. So A is equal to 0 hash 100. You copy, enter, once again paste, change the inputs here. A is equal to 0 hash 100 is the delay, nanosecond delay. A is equal to 0 hash 100, A is equal to 1 hash 100. Save this one. Then select the simulation tool here. It will be available. So go for this one. Select iSim simulator, behavioral check syntax. simulate behavioral model. See, you are getting the waveforms here. Inverted. 0 means 1, 1 means 0. This is a switch level and it's a waveform. Okay. You have to write down all these things, and you neglect this green color part. They are all comments. You don't write this one, only write this one, remaining code, whatever it is there. This is test bench code, and this is Verilog code.
Okay.
This Verilog code and this test bench code you have to write in the right part of the book or record, and in the left side you have to write the circuit diagram, waveforms and the truth table. So next, for the next program, what you have to do, just you right click on this, remove this. Okay, then go for implementation. There are two parts are there, implementation and simulation. Test bench is linking to simulation, Verilog code is linking to implementation. So right click and remove, and here also right click and remove, but package will be available. Again select this, go for new source and select Verilog module buffer1. Okay, you write the buffer code. After that again next completed. After that check syntax, again right click here, again go for new source, you are getting here Verilog text fixture. After that you give the another name, buffer test1. Next you are getting the test bench code like this for buffer. You change the input positions here, a is equal to 0, a is equal to 1, like that. Save, then go for simulation, select the main module part here in the simulation, then behavioral check syntax, then simulate behavioral model, you are getting the waveform. So that completes. Okay, you have to do all the gates by using this logic.